as this is an important lecture to discuss. No? So let everybody join first. Please send a message also, because transistor is the base of basic electronics actually. अगर ये चीज समझ आ गई तो सब समझ में आ गया, समझ लो. So जो भी coming lectures हैं, please don't miss those lectures. They're very important regarding the transistors, as this is the backbone of semiconductor industry or any electronics industry. Couldn't be possible without the evolution of transistor. Okay. So if you have any questions, आपने पढ़ा है transistors पहले, but even though I am just repeating it for you in a different way, right? जैसे डायोड भी पढ़ा था ना, तो डायोड को भी the way I have presented it, it is from application point of view. And even if आपके पास कोई question हो, you just post it to me. Okay? कई बार ऐसा होता है ना, पढ़ते पढ़ते कोई question ध्यान में आ गया. You just mail me. अगर आपको लग रहा है होगा तो you can mail me. You can post this question on the classroom. Okay? Because sometimes when you are at home, you are just reading the things and you just find out that okay, I'm not able to get it. So you can just post that question at that time, and I'll see it later and tell you according to my convenience. Okay, right? You can mail me also, right?
Okay, sir.
क्लासरूम पे पोस्ट कर देंगे तो और बेटर है, कोई दिक्कत नहीं, राइट? ओके. अगला आपको, if there is some group of your class, just post the message that the important lecture is going to come, है ना? I'll wait for 1 or 2 minutes. Okay, I think I must begin now, right? So I'll discuss about transistors. In the last class, if you remember, we have started discussing about the bipolar junction transistor, and I've described that how the bipolar junction transistor is being or is helpful in. Sorry, just my screen is visible to you.
Yes, sir.
Okay, so this is what we have studied. If you see, uh, this is the structure of the transistors, and this is how I have depicted it. That how emitter, base, and collector, and why the bipolar junction transistor's name is there. Okay, and how is the transistor action. We are going to talk about the Fermi energy levels also. This is what we have seen. Okay, that how the Fermi energy level and all about this. Today we'll discuss about transistor functions. I mean transistor action or operation of a transistor. Actually. So the process of applying DC voltages across the different terminals of a transistor is called as biasing. Have you heard this term earlier?
Yes, sir.
What is the meaning of this? Bias means favoritism. Okay, you're just favoring something, isn't it? ऐसा होता है ना? Hello, you can correct me.
Yes, sir.
So we are favoring someone. That means biasness towards him or her. Okay, so same here that we are favoring the transistor by applying DC voltages across its terminals. What are the terminals? We have three terminals: emitter, base, and collector. We are applying the DC voltages across it in order to favor it. Why we want to favor it? So that it can work as per our choice. Okay, so that is why the term biasing is being used. So if I talk about this transistor, this is okay. So this is N positive, this is P, this is N. Right? We know this is emitter, this is base, and this is collector. So if this is N positive, So what we do is we are just forward vising this. इसको forward wise करना हो, so N is connected with negative and P should be connected with positive. Okay, so this is going to forward wise the emitter base junction. Am I right? If I apply a battery like this, so emitter base junction is forward bias. If polarity of the battery is being changed, it is reverse bias, right? And with the help of this, so this is something like this. This is called as this voltage is called as V and E and B. Okay, and this is called as VC. So as base is common, that's why this is called as emitter supply. This is emitter supply and this is collector supply voltage. You might have seen that this VCV is larger than this VEV. Okay? Right? So positive terminal is connected with the N and negative. So this is a reverse bias and this is going to make it forward bias. So and collector base terminal is a reverse bias. Right? And if we see its depletion regions, so they will be small as this terminal is forward bias and this will be large. Okay, so this depletion region is being narrowed and this depletion region will be increased because of this voltage, right? Because there is a junction J1 and junction J2. Okay, so junction J1 is being forward bias and junction J2 is reverse bias. So it is being narrowed and this is being widened. Okay, now we have to understand its working actually. Okay, but how it is going to work now? This is this you can say is the biasing of a transistor, right? So we have four possibilities. We cannot make this emitter base junction reverse bias. Why? Otherwise, this junction J1 will be very large or it will be widened, and that means there is no flow of charge carriers. So we have to make it turn on instead of turn off. So generally forward wise or reverse wise ऐसे रहते हैं. Now we'll see its functioning. And अब होता क्या है देखिए, इस केस में if this and so these are the two reasons. These are the depletion reasons actually. Okay. Now we know that we have electrons majority carrier here in the emitter, holes in base, and in the collector also electrons. So here if you see, because this VEB, this is going to emit the electrons. Electrons are entering into the, and current is moving up because of this battery actually. This is nothing but this is a battery, or you can say DC voltage. This is VCB. Okay, so definitely current is flowing towards this side and electrons they are moving into this. Okay, so more number of electrons they are moving inside this, and this junction J1 is, or the depletion width of junction J1 is being decreased as it is forward bias. Okay, forward bias है, and this is a reverse bias, right? So when the forward bias at emitter base junction, that reduces the barrier potential. Okay, so electrons are coming from this battery into the emitter. So if you see in the emitter, we have large number of, or there is a large concentration of the electrons. Okay, and these electrons they will definitely move towards the base, because this junction will be, or if we are, or it is going to cross this barrier, and here we have, if you remember, the majority carriers in the P and P junction is, or this P base is, they are poles. तो यहाँ होल्स हैं. Okay, so these electrons which is having very high energy, they are coming from this side, they will cross towards this side, and they are going to recombine here with the holes, right? But because this base width is very small, क्योंकि because of the depletion region, so base width वैसे भी सबसे कम रहती है. So these electrons will move towards the, few of them they are recombined with the holes and make the bond, and rest of them they are going towards this. So जो भी यहाँ electron होगा, because this is positive, so definitely this is going to attract like this. Okay, isn't it? Because this battery is going to favor these electrons which are here towards this battery. So current is moving opposite to that. This is IC. Okay, जितने electrons base से जा रहे हैं उतने ही base में enter भी. This is something like that. Okay, so अब होता क्या है देखिए. Suppose we are taking 100 electrons. Emitter में है 100 electrons. In the base, 5% of them they are recombined with the holes, and 95% of them they are going towards the collector. Okay, so collector is reverse bias. It creates a very strong electric field. तो यहाँ, because of this we have very strong electric field. Okay, and it collects, this field collects the diffused electrons. जो भी यहाँ से electrons जाएंगे, this is going to collect those electrons in the collector, and these electrons will enter into this, the collector, and this flow of electron into the base region, from here they are going to recombine with the holes. So this is how it is going to work. एक तरह से यह है कि 100 इलेक्ट्रॉन चले, because of this biasing technique 5% उसमें रिकम्बाइन हो गए, 95% कलेक्टर ने कलेक्ट कर. These BEB and this VCB, they are going to provide the biasing, favoritism for the working of a BJT. Okay? Any questions regarding this? Or इसका nomenclature means BEB means it is in between emitter and base. VCB means collector and base. BE means it is emitter versus ground. Yep. Base means base versus ground. Because another terminal is like this, 0. The second terminal is here in this case, that is ground. And here one is collector and another one is base. That is the difference. Okay? So this is what we can see is the energy band diagram. So we know that this is emitter. emitter के साथ बेस ऐसे था, समथिंग लाइक दिस, ऐसे था ना,
Yes, sir.
राइट. नाउ if you see, we combine, this is energy levels, right? This is the balance band, this is the conduction band. Okay, so because this junction, J1 junction if you see, and J2 junction if you see, J1 junction should be, it is less steeper, like this. Okay, because it is forward bias. And if you see this, the reverse bias junction, this is very steep here. Okay, so that's why it is having large potential hill, and this is having small potential hill. That means potential barrier actually. So when this electron uh, from the emitter supply, they are coming into this, they are going to recombine with the holes. 5% of them, not all of them. Okay, बाकी सीधे चले जाएंगे ऐसे. Can you see the concept?
Yes, sir.
Okay, क्योंकि यहाँ से एनर्जी ड्रॉप होना शुरू हो रही है, तो यहाँ से थोड़ी सी एनर्जी ड्रॉप हुई है, मीन्स फॉरवर्ड बाइज हुआ है ना, दैट्स व्हाई इट इज गोइंग टू रिकम्बाइन विद दिस होल्स एक्चुअली, राइट. ये होल्स आप देखो यहाँ क्यों है, बिकॉज दिस इज पी टाइप, एंड पी टाइप में इट इज अबव द बैलेंस बैंड, राइट, बिकॉज ऑफ द डोपिंग इम्प्योरिटी, बोरोन, एल्यूमिनियम, गैलियम, इंडियम, इस तरह से. दिस इज पी टाइप. सो इफ यू रिमेंबर, यहाँ पे दिस इज द accepted energy level in case of p-type semiconductor. So they are going to recombine 5% of them. Rest will go into the conduction band because यहाँ से supply दी है, तो these electrons which are coming from here, they are in the conduction band. Okay, and here we have majority of electrons here. एक तरह से यहाँ electrons बढ़ जाएंगे. जैसे यहाँ electrons बढ़े, there is diffusion, and this battery is also going to, because this is positive, ये पॉजिटिव है ना, सो ये इन इलेक्ट्रॉन्स को अट्रैक्ट करेगी इस साइड, राइट. बट एज these electrons are coming down to this side, it means this is higher energy side. अगर ये देखो तो ये ज्यादा एनर्जी लेवल है, and this is lower energy level. Can we see?
Yes, sir.
So that means they are going to lose some energy. Okay, when the electron from emitter, they are coming out of that, going to recombine with the holes at the base, and remaining of the electrons, they are going to be collected by the collector. But as the energy is coming down, because we have a large potential hill, large potential barrier here, so here they are going to be collected, but that energy is coming down, so that there is change in the energy level, and that energy is being radiated in the form of heat, right? That's why the devices, semiconductor devices, they are getting heated up. Okay.
Yes, sir.
Okay. Right. So I hope no you understand it now. ठीक है? So that is how it works actually. अगर यही बात हम करते हैं PNP ट्रांजिस्टर्स की, थोड़ा बड़ा बनाता हूँ. Okay, now if this is P positive, this is N and this is P, इसको forward wise करने के लिए this is like this, isn't it? This is like so this is forward wise, so barrier is small. This is junction J1, this is junction J2. Okay, so we have again, right, holes here as majority carriers, and this is positive, so definitely it is going to inject the holes into it. These holes, they are going to recombine, 5% of them they are going to recombine with the electrons of the base, because this is base, and the rest of them they are going towards the collector, right? So जो यहाँ holes पहुंचेंगे, because this is negative, so that's why it is moving towards this side. Okay, right? So one interesting thing which we have to see is that this is current IE, this is IB, and this is IC. So if you see, emitter current is nothing but it is IB plus IC. यही है ना? Because 100 यहाँ से चले, 5 यहाँ है, 95 यहाँ है, right? So emitter current is equal to base current plus collector current. Because this is as per KCL, Kirchhoff's current law. Okay, and it is true for both NPN and PNP. इस केस में ऐसे था, दूसरे केस में इसके अपोजिट है. This one, if you see, because these two currents are entering and this is coming out. Okay, any questions regarding this? किसी को कुछ पूछना हो?
एक बार सर J2 पे रिवर्स बायसेक्शन आता है क्या?
हाँ, वो तो है ही. J2 रिवर्स वाइज ही किया है आपने. दिस इज J2 ना, तभी तो बड़ा है, आप देखो।
अच्छा, जो ऊपर वाला है उसमें।
ऑब्वियसली बिकॉज बैटरी इज लार्ज ना, और ये रिवर्स वाइज है। आप देख नहीं रहे हो, जंक्शन J2 बड़ा है, इज वाइडन्ड एज कंपेयर टू जंक्शन
ये
J1।
वाला। ओके
ठीक
सर।
है,
यस सर।
ओके ओके। और नीचे वाले केस में भी ऐसा ही है। ओनली थिंग इज दैट हेयर होल्स आर मेजॉरिटी, होल करंट इज द मेजॉरिटी कैरियर। ओके, सो दिस इज सिंपल वन, राइट। सो इसके अलावा भी करंट फ्लो होते हैं, मतलब, राइट। इट इज नॉट द, दिस इज जस्ट सिंपल वर्किंग विच वी आर इंटरेस्टेड इन। और भी एक दो पैरामीटर हैं विच वी आर नॉट इंटरेस्टेड इन, बट वी शुड नो अबाउट देम। दैट इज कॉल्ड एज लीकेज करंट एक्चुअली। Okay, but as collector has to collect, that's why it's largest. It is larger in size. It is also going to dissipate heat, so it needs larger size. That's why collector का size हमने large रखा है. And emitter has to emit, so it is having highest doping. Okay, but the thing is, this structure is asymmetric in nature. Symmetric नहीं है ना, तीनों अलग अलग साइज के हैं।
यस
ओके, ये थोड़ी सी एक दिक्कत है इस केस में, राइट। हाँ जी, किसी को पूछना हो कुछ क्वेश्चन जो आपने पहले किया हो और समझ ना आया हो। आपने पहले भी पढ़ा होगा ना सेम ही टॉपिक। हेलो,
यस सर।
+2 में एनी क्वेश्चंस, इसमें कुछ समझ ना आया हो। आई थिंक सब ठीक है।
यस सर, आगे सर।
बाकी लोग नहीं बोल रहे हैं, जस्ट राइट डाउन यस और नो, है ना। ये समझना बहुत जरूरी है एक्चुअली। अगर ये समझ आ गया आपको तो जस्ट राइट डाउन योर आंसर यस और नो। ओके, सो वी हैव 4 possibilities, different operating conditions for transistors. For a transistor, so we have 4 possibilities. Okay, So you see here, we have this one junction is forward bias, and this another one is a reverse bias. This is one of the most prominent forward reverse condition जिसके बारे में अभी डिस्कस किया हमने. Okay, then we can make both of them forward bias. That region of operation is called as saturation. जो हमने डिस्कस किया that is called as active. Okay, एक्टिव किया हमने, क्या किया हमने, एक्टिव रीजन ऑफ ऑपरेशन डिस्कस किया. The first one, that one is forward bias, another one is reverse bias. This is also called as linear region of operation. Active means we can use the transistor as an amplifier in the active region or the linear region. This is the most important thing. Okay, do you know what is amplifier? Hello, amplifier पता है?
Yes, sir.
है ना? So amplifier is always operating. They are designed with the help of BJT, and BJT we are operating that in the active region actually. That is how we can utilize it as an amplifier. So the biasing is like this one. We talk about the second one, that is saturation. Means saturation we are talking about. So both the regions are. What is the meaning of saturation? Means,
Minority current.
हाँ जी. So means if we have input and we have output, so output is not going to change with respect to input. Whatever input you are changing, output remains the same. Okay, and in the linear region, if you see, it is something like Ohm's law, like this. That input is changing, output is changing linearly with respect to that. Okay, right? So that is the difference between linear and active saturation region. Saturation means output is getting saturated. Okay,
Yes,
ठीक
sir.
है? So that is the meaning of this. And the third one is both are reverse bias. अगर दोनों reverse bias करते हैं तो क्या होगा? If we are making both the junctions reverse bias, is so means दोनों junctions बड़े हो जाएंगे. ओके, ऐसे हो जाएंगे एक तरह से. डिप्लीशन रीजन ऐसा हो जाएगा, एक तरह से बहुत बड़ा सा हो जाएगा, isn't it?
Yes, sir.
And both the PN junctions they are in the off state, so ये off हो जाएगा. So this is cut off basically. That's why its name is cut off. And if you reverse bias it, and the second is forward bias it, तो हम उसको इस सिचुएशन को इन्वर्ट कर रहे हैं एक तरह से. That's why it is inverted. Okay.
Yes, sir.
So these are the 4 stages. Okay. Any questions regarding this? आपने पढ़ा होगा ये सब, but I'm just repeating it for you and making it more clarifying. तो saturation का मतलब ये है, linear reactive का मतलब है linear reason, a relationship between input and output. Whenever we talk about it is input versus output. Okay.
Yes, sir.
Right. Okay. So I think this is enough for the day. काफी है. Hello.
Yes, sir.
Okay. So before finishing it, I'll just start the next topic that we have different transistor configurations. We know that is common emitter, common base, and common collector. Common base and common collector. Right? So the symbol of the transistor is like this. This is NPN transistor. This is base, this is collector, and this is emitter. Okay? So this is the input side and this is the output side. So the emitter is common to both of them. That's why this is common emitter configuration. Right? And if base is common to input and output, it is means हम तीनों को कुछ किसी भी तरह से ले सकते हैं. But the thing is because it is asymmetrical device, so functioning will definitely going to change. Asymmetrical है ना device, so इसकी functioning फिर बदल जाएगी. अगर हम अलग अलग, this is common base, input यहाँ दी, so this is base, this is emitter, this is collector, something like that. इसी को ऐसे यूज कर सकते हैं. Like this. This is input side, this is output side, something like. So it depends upon you how to utilize it. But this is, you can say, the configuration of or the symbol of the transistor. And PNPs, we know this is PNP transistor. Okay. So the purpose of transistor is why we are studying this topic, because we can use it in various applications. ओके, वी कैन अप्लाई इट. कहाँ अप्लाई कर सकते हैं? और इसकी फंक्शनिंग में अगर आप देखो तो व्हाट वी हैव इज वी हैव नथिंग बट दिस इज NPN, मींस दो डायोड है एक तरह से, isn't it? जिनको या तो ऑन कर रहे हैं या ऑफ कर रहे हैं. ये दो- एक को ऑफ किया, दूसरे को ऑन किया, ये दोनों ऑन कर दिए. ओके, और दोनों ही ऑफ कर दिए. So this is active region, this is inverted region, invert of that. This is, if both are on, it is saturation, and both are off, it is cut off. Right? यही कर रहे हैं ना?
Yes, sir.
And this is inverted region. Invert means जैसे A का invert है A bar, means complement of the above one. This is complement of the active region actually. That is what you can say. Okay, but operation or the output may not necessarily be same, as BJT is an asymmetrical device. Fine. Okay. Anyway,
Yes, sir.
thank you very much for being with me now. Any questions?
No, sir. Thank you, sir.